Next up, we've got Clarence, who is one of the newer members of the team, but definitely taking everyone by storm. He's going to be talking a little bit about the progression that we're seeing in the web application development space and the approach that we're taking to address these evolutions. Welcome, Clarence.
All right, hey everyone. My name's Clarence, and I'm an engineer that's working across the YUI and the Modown teams. And I'm here to talk to you today about YUI and the new server-side front-end. And what the new server-side front-end is that as a front-end engineer, we're starting to do work that's moving over to the server. We're not just building things that are just like single, one-off browser scripts anymore. We're doing things that take advantage of the full stack, from rendering the HTML to binding those elements. And this is something that we've been actually working on for quite some time, about a year now. But it's something that Nicholas Sakas recently popularized with one of his blog posts. So let's take a look at what we're going to talk about. So first of all, we're going to take a look at this from a few perspectives, like how do we get here in the first place? So how, as a JavaScript engineer, do we start moving from just browser-side components all the way to what work would be considered originally the realm of the back-end engineer? And we're going to take a look at some of the older frameworks, some of the older web frameworks, and how we moved from those frameworks step by step over to what we have today. And we're also going to look at the benefits. Why is it good for someone to start moving over to the server? We're going to take a look at some of the benefits for users, so that with like today's web apps, how we can give users a better experience with better performance so that they can get to the information that they want to see faster. We're also going to take a look at the benefits for developers. We're going to see how we can split up our code more easily, how we have a better separation of concerns between what the role of a back-end engineer should do, which is to focus on the business logic and sending the data back out, and what the front-end engineer should do, which is the work that they're going to do on presenting that data back to the user. And finally, we're going to talk about some of the work that we've been doing over the past few months and how you can use these components with your YUI code today. And maybe not even just YUI, but you can use it with any other client-side JavaScript framework that you're using. So let's take a step back and take a look at some web frameworks that already exist. So we've seen a whole bunch of abstracted server-side only MVC frameworks. And these are things like Rails, like Django, and Cake PHP. And how these frameworks work is that you have a browser, and with the browser, you make an HTTP request over to the server. The server fetches that data, mangles that data into a form of HTML, and then that HTML is sent directly back to the client. And with that, that's good in a way. You get fast results back because the browser, all the browser needs to do is just parse that HTML and display it to the user. And the only problem that we have with this is that between every state, between every page that you need to go through, you would need to do basically a full page refresh. You would need to do a round trip between the browser and the server every single time you want to go back. And that's good in a way, but at the same time, we want to create newer experiences, a way that people can start creating applications that are closer to native applications, that are smooth and that have nice transitions that we're looking for. So after that, we started seeing a shift towards the idea of a service-oriented architecture. The idea that people are starting to build on top of build REST APIs and that just spit out JSON and XML data. And the idea behind this is that you're standardizing how you access data over HTTP. And HTTP is something that you can access from any programming language. So the benefit of this is that now that you have a dedicated backend, no matter what front end you use, whether that's JavaScript or you're making a native mobile application and using Objective-C, or just any other application that can access HTTP, you can do that. And so an example of this that we have at Yahoo is the idea of YQL. And with YQL, so if you're familiar with using it with YUI, all you need to do is y.yql and your YQL query. Or in Objective-C, it's the same thing, except it just returns an NS dictionary. And the idea is that, again, as long as you can access HTTP, that's all that matters. You only need to know one way of accessing that data, and then no matter what platform you're on, you can access that data in exactly the same way. So let's move a bit forward. But we sort of brought this up during a question in Eric's talk, and it's the idea of the single-page app and larger client-side MVC frameworks. And so these include things like Backbone, the YUI app framework, Ember and Angular, all of that. And the benefit of these is that you have the idea of partial rendering, and that you don't need to do a full page reload again. You can just render a portion of the page. And if you just render a portion of the page, you can also have those like slick JavaScript animations. And they give you that really fluid response so that the people using your application can't tell the difference between whether they're using a native app or whether they're using a web app. And you have more benefits than a regular native app, since on the web, you can access that no matter where you go, no matter what computer you use. And now that you also have like a better separation of concerns, as we talked about before, you have your HTTP API, and your server just provides the data. Your backend developers, they don't need to care about what the HTML looks like anymore. They don't need to care about whether you need like a date in a specific format. They just need to provide a date, some data, and that's all that they need to give you. And what happens with that is that now instead of having the browser make every single request, do a round trip, what you do is you send a little skeleton with the app seed to the user's browser. And the user's browser dynamically loads data from the server as JSON. And when you do that, you basically just bootstrap the application that way, and you create HTML elements on the fly and dynamically render them onto the page. And so that you don't need, if you have the same header, the same footer, you don't need to re-render those again. All you need to do is basically re-render the portion of the page that you're changing. So this is great, and now that we have almost purely native feeling applications on the client side, but what are the problems with it? They can't be all great, right? So with those, we have problems with performance. And the problems with that is that if you're on a slower mobile device, then the time to your first initial content, how long it takes for you to actually reach that initial content takes a lot longer. And that's a problem if you have a user that just wants to see that content. If they're coming to your page from Twitter or from Facebook and they just want to read that one blog post you have, you don't want them staring at a blank screen for a really long time. And you also have the idea of some SEO concerns. Not all search engines right now can index JSON data. They can't crawl, since your server isn't spitting out HTML. They can't just easily crawl it like they normally would. With Google, for instance, you would need to format your JSON data in a very specific way. And a bunch of other search engines won't even be able to index it. So what you would need to do is that you would need to come up with a way to either generate that HTML. You can, some ways that people have done that with today's single-page apps is they use Phantom.js, for example, to generate the HTML. But that doesn't always work out, and that also takes more memory and more computational time on the server. And that's not something you want. The point is you want your users to be able to reach your content fast, and you want them to be able to reach them from search engines or anywhere else. So let's take a look at a real-world example. And let's take a look at Twitter. And what Twitter started out as is they started out as a purely server-side Ruby on Rails app. And as a purely server-side Ruby on Rails app, they had to go, their users had to go through a page at a time. So when they clicked on a link, they would need to do a full page refresh every single time. And what they really wanted to do was they wanted to provide a new experience for their users. They wanted to give their users a really slick feeling. They wanted to give their users the chance to just see tweets as they came in. And they did that, and they made New Twitter. And what New Twitter did was it was similar to their mobile app. And what their mobile app and New Twitter did was it directly accessed content from their REST API. So there was no longer any server-side rendering at all. All they had was that app seed, And what that app seat would do was basically make an AJAX call over to the server, take that data, parse it out, and render it using client-side templates. And that was great, but the problem was that a lot of their users were complaining. And the reason that their users were complaining was that they weren't seeing content. They were seeing this giant blank screen. And that's something that they realized was a big mistake. And so what they did was this. So according to Dan Webb, who was the Twitter engineering manager, they decided to do a hybrid approach. They decided to render the initial page load on the server, and then everything after that would use the smooth client-side movement that they had there. And by doing that, they realized that they got a lot better performance benefits that way. By rendering that first page on the server, it dropped their page load times to 1/5 of what they originally were. Because what happened was that their client no longer needed to do another HTTP request over the server, get JSON data, parse that out, put that into a template, and then finally append that to the DOM. All it needed was it went to the server, got HTML, and that HTML was just shown by their browser. And that's what users want sometimes. When they go onto your page, they want their content as soon as possible. So the idea is that this is what we want to do too. It's the idea of a client-server framework and the best of both worlds, so to speak. It's that we take the benefits of a client-side framework, so we can create single-page apps that are really smooth, that have that native interface. But we also have the idea of rendering that first page load on the server. And by doing that, you solve all of the problems that we talked about before. You have fast server-side rendering, and search engines can index your application because all you're serving is basically HTML. And beyond that, you're also supporting the idea of progressive enhancement. For users that have older browsers, for instance, such as IE6, what they can do is that if your app has some JavaScript that their browser doesn't support, they can still get at least a decent use of your application because they can see the HTML that's being rendered. And other than that, like I said before, you'll have that smooth experience. So it's basically like creating a single-page app. But what are the problems with this? Like, if this is so great, if we got rid of every single possible negative side of this, why is this something that not everyone is doing? And with this, it's that it's a bit difficult to do this if you have two different languages on both the server and the client. If you're using Python on the server, for instance, and JavaScript on the client, you come up with the problem that there's not that much shared code that you can really use since they're not interoperable. You can't just immediately say, I want to use my Python code directly inside my JavaScript, or vice versa. There's no easy way of sharing it other than doing a transpilation of the code. And the good example of this is if I was making an app that did something like that did render something on the server first and then passed it along to a client, what if I wanted to do something like internationalization, for instance? If I wanted to be able to translate certain text on the server and do it again on the client, I would need to write internationalization code once on the server in Python, and I would need to write that same code again in JavaScript. And that's bad. That's not something that we want to have. And another problem is that you add more overhead when you do this. You're basically creating an intermediate layer between your data and the client. And by doing that, there's more things that can go wrong. And so to solve both of these problems, what can we do? So our solution is Node.js. And the idea with Node.js is that it's JavaScript on the server. So basically, a lot more of your code can be shared. You can write code on the server. So when you have code that's used on both sides, such as your internationalization code, that's something that you can write once, and you can use in both environments, on both the client and on the server. And we're also taking advantage of micro-frameworks like Express and Connect. These are things that are being used by the Node community today, and they've been pretty popular. And we want to not create a new way for what people are using. We want people to use these micro-frameworks the way that they're used to using, and we just want them to add a little bit more so that they can still write their single-page apps, and they can still do server render. And also with Node.js, you also have build tooling with grunt. So basically, your entire stack becomes JavaScript. There's no more of the idea of context switching. You don't need to write your build tools using a make file, for instance, your server code in Python, and your client-side code in JavaScript. It's JavaScript everywhere. And basically, it's one language, client and server. But the problem is that, are people really using these things effectively? Are they really using them in the way that they're meant to be used? So according to Eric Lorenzano, we're not. We're using these completely wrong. And instead of coding in one language, we're coding in two. On the client side, you have the DOM APIs. And on the server side, you have the file system APIs. So you basically, what ends up happening is that you have to write server-specific JavaScript, which is Node.js code, that JavaScript code that only works on the server because of Node.js, and JavaScript code that only works on a client because of the DOM. We can't easily fix that unless we use something like JS DOM, but we realized that that was something that was very computationally expensive, and that wouldn't work out for a real production application. So what our plans are is that our goals are to create an app that 80% of the code is shared, or at least as much of it as possible. So let's step back for a bit, and let's take a look at an HTTP request going through your application. What happens to that HTTP request, and what goes on? So when an HTTP request comes into your application, there's a bunch of things that can go on. First thing that happens is that you need to personalize that HTTP request. If the user that's requesting something from your application is in a different locale than you, so what you need to determine what locale they're in, whether they're in the United States or in French, you need to figure that out. Another thing that you might want to do in terms of personalization is determine whether the user that's requesting content for your application is on a mobile device or on a desktop or on a tablet, because that way you might serve different code to them depending on the instance. And so that's something that can only be done on the server for now. After you classify that HTTP request, you need to figure out how to handle the routes. Where are they looking to go? If they go to this URL, what sort of data are they expecting to get back? And that's something that you can do on the server using a server router. And you can also do that on the client using a client router, such as the one that we have in y.router in YUI today. Or if you're not using YUI, it's something that you can do using a backbone router or a router in any purely client-side JavaScript framework. After that, once you know what path you're going to, what data do you need to get? What sort of resources do you want to have? And in this case, since we're getting data from a purely HTTP API, such as YQL, that's something that we can do on both the server and the client. How they get the data, how they access the actual HTTP resource, it might be different. So with Node.js, you might be using the request module, for instance. And on the client, you might just be doing a pure AJAX call. But the idea is that we want to abstract that out. And that's done in YUI today. And with YUI, when you're using Node.js and you're doing an I/O call, that uses the request module. And when you're using it on the browser, it uses y.io as you know it. And finally, the idea of formatting and rendering. So when you format code, the idea of taking that JSON data and putting it into a template. We want to be able to share templates. And since we're using purely string-based templates like handlebars, that's something that's a lot easier for us to do. So handlebars templates we can use on the server, and we can also compile them into JavaScript functions and use them again as YUI modules. So that's something that we can do on both sides. And finally, the idea of UI binding. That's something that you can only do on the client. So that's basically the idea of wiring up your DOM events and wiring up anything that specifically needs to access the DOM API. That's something you can't do on the server unless you use something like JS DOM, which that's our goal to try to avoid. We don't want any leaky abstractions with the DOM on the server. And so looking at this, we have three main things that we can share. We can share how we handle routes, we can share how we handle resources, and we can share how we handle templates. And that's our goal, at least for this. So with sharing data between client and server, we came up with a small module that people can use to handle this, and we call this express state. And what we do with express state is the idea that it's a secure and simple way that inside your Express application, it's how you can share arbitrary data. So whether that's like data such as your Flickr API key that you need to have on both the server and the client. So for instance, you want to be able to access YQL on both sides. So you want to use the same API key for both of them. So what express state allows you to do is that it basically just creates variables that you can use on the client. You specifically state where you want that variable to be inside of Express. And then you can either expose it at the application level, so it's available to every single one of your routes, or you can expose this at the request level, so it's only available to one of your resources. And so how do we use Express State to share that data? How do we use it to share routes? How do we use it to share resources? And how do we use it to share templates? And so the idea is that we have the idea of route handling. And with route handling, it's the idea that we also created another module for this. But it's that since you have server-side routes and client-side routes, and they both link to the same things, you don't want to have to write those routes twice. And we use Express State inside another module we wrote called Express Map in order to do that. So the idea is really simple. What you do is that you have a route, you do app.map, the path name that you want to give it, and a name of the route. So this name of the route can be accessed anywhere. And from now on, you'll reference your route by that name so that whenever you need to change that URL path, if you ever have to change it, you don't need to go through and change every single instance of that path that you hard-coded into your application. And once you map that route, you can expose it using the idea, using a function inside of ExpressMap called app.getRouteMap. And what app.getRouteMap does is that it takes all of your Express routes, so all of your app.gets, all of your app.posts, all of your app.puts, takes those and puts it into a nice JSON object and exposes it on the client so that people can use it. And what that looks like is that we're exposing it under myapp.routes. And so on the client, what you have is that myapp.routes is just magically available to you. You can access it like you would access any other JavaScript variable. And after that, if you're using the YUI app framework, we made it really easy for you in the last release of YUI to take these serialized routes and turn them from express routes over into y.router routes. And that's something that we'll be continuing to work on in the future. But this is something that you can do. So you no longer have to have two routers. You don't need to have an express router, and you don't need to have a y.router. You can basically just write your routes once inside of Express, and that route, all of your client-side routes will automatically be created for you. So we also have the idea of fetching resources. And with that, it's how do you access data? And since for us, we tend to get data using YQL. But for people outside of Yahoo, you might be using a REST API or some other HTTP resource. And with that, you can create these resource models that work on both sides, since all you need to do is access an HTTP resource. So what we did here was we created a simple weather model. And with that weather model, what you would do is basically you would just use YQL. And YQL would work on both the server and the client. That's something you can use on both sides. And that's, again, code that you can reuse. You don't need to write a model on the server saying that I want to get YQL like this. And you don't need to write another model on the client saying I want to get YQL like that. It's the same thing. You write less code, there's less possibility for error. But the problem is another thing. Now that we're actually sending pure HTML over to the client, what's going to happen? We don't want to, since we have HTML over to the client, it might not always be easy to just parse that HTML and get that back into our application logic. So we also need to use Express State to expose those resources so that we can bootstrap our app that way. And so how that works is like this. So basically what we would do is we can fetch the data on the server once using, for example, our weather model and just do weather.fetch. And then that data that's returned, we can expose it on the client. So what happens is that you have the HTML, and you also have the JSON representation of the data that you send over from the server. And this might seem like you're duplicating the data, but it's not as much of a problem because of when you gzip your code, that duplication tends to go away from our experiences. And so with that, you can immediately, like what we did before with the routes, you take your models, and with those models, that data is serialized. Again, it's immediately accessible on the client. And after that, you can create a new Y.model out of that, so that now you have access to all of those change events. You have access to everything that you want to do that you would with a regular model, except instead of having to wait again and make an AJAX call, get that back, and finally put that into your client, you have that immediately from the start, from the server. And that's the benefit of that. And finally, with templates, you can format and render them in a very specific way. So because of that, you can use tools such as Grunt to compile handlebars templates, or you can use another tool that we've built that Carity will talk more about later in his Modon talk called Locator. And with this, the general idea is that you can share templates if you're using something that we support, such as handlebars, for instance. And with handlebars templates, you can use it once on the server, compile them, and using the y.template API in YUI, what you can do is you can access those templates through the template registry and basically take those templates and use them in the same way on the client. So that way, you no longer need to go to a server and do a full page refresh for that. All you need to do is get data now, and now you have the template, so you just interpolate them together, and then you can have your HTML. So now that you can do partial rendering, it's a lot easier, it's a lot smoother. You can add JavaScript animations or CSS animations, and that'll give you that smooth native experience that you want. So let's take a look at a quick example, actually, and let's let's have a demo of basically what the difference is for an actual user between server-side rendering, client-side rendering, and combining them both in our hybrid approach with the client and server frameworks. So basically, for what I did on this is that the application that I made for this demo was taken from a sample application that I made for Code for America. And the basic idea of this application is that it's basically a very simple application that takes government data, gets it from the city of San Francisco of all the different artwork that appears inside the city. And what it basically does is that it takes that artwork, mashes it up with Flickr photos, and it creates a really nice app where you can see like all of the different artwork that goes on in San Francisco. And so I made 3 versions of this application. So there's a server-side rendering only version, there's a client-side rendering only version, and there's one that we use both. And an additional thing that I did with this is that I throttled the data on the application server. So the idea of this is to simulate what would happen if you were on a mobile device that had a really bad network, for instance, or you were on something that just didn't have a lot of computational power, or even if you were at a conference and you had really bad Wi-Fi. So the idea is that we'll take a look at what that looks like. And so we'll start off with the server-side rendering version. So here's what it looks like. And when you first land on the page, it takes a long time to load. But what you can do is that as you keep going, you still need to do a full page refresh. And you can sort of feel that delay. You can sort of feel that if you have a slow network, it takes a really long time for things to fully load, since it needs to re-render all of that HTML again. So on the client side, basically what we have is this. All right, so it's loading faster than I actually expected it to. But the idea is that what would happen is that you would have a giant blank screen where what would happen is that you wouldn't be able to see any of these pictures. You would only be able to see the layout of the HTML at the very beginning, which is just the header and footer. And it would take some time before you got that flash, and that flash would basically show you all the photos. And that's something that happens a lot when you have a purely client-side application that needs to make a second HTTP request to get the data, and then it takes a lot of computational time just to render it back out. But with that, you also have a bit of a smoother animation. It's easier for it, it's a bit faster for it since it doesn't need to re-render the entire thing. All it does is that it re-renders the portion of the page that needs to be changed, and that's it. And finally, this is the one that combines both of them. It combines both the server and the client-side techniques that we have. So when we take a look at it at the beginning, what we have is a pretty fast page load. And after that, when we go and transition to another section of our application, it's pretty fast. So basically, we have the benefits of both. There's no longer that delay that you have with just each server-side page change. And you also have that like smoother animation or that smoother like page transition that you would have with the client-side app. And so that's the benefit of it. So that's something that your users will see, especially if they're on mobile devices, which they're definitely on a lot more nowadays. So by doing this, we're trying to make the best out of mobile web. And by doing this, we want our users to see their content fast, and we also want them to have close to native experiences whenever they're making apps. And this is something that you can consider when you're building applications of your own. So to sum up, basically our goal, again, is to move the front end over to the server. We have faster load times and a faster time to initial content. And that's something that's great. That's great for the user. And that's definitely something that they'll definitely appreciate. And the idea is that you also have a modern UI. You can create these single-page applications. And the goal that we're hoping to work towards is that you can use this with any client-side JavaScript framework you want. If you're using Ember, if you're using Angular, if you're using Backbone, if you're using like the YUI app framework, we want the idea that you can share this code in the same way, but how you adapt it to the different frameworks is what we'll need to be building. And moving front end to a server is also better for developers. What you're able to do there is that as a developer, you can finally split up your team like appropriately. Your backend developers don't need to deal with HTML anymore. All they need to focus on is getting the data out to you in a way that you can use. And the idea that's this is better for your company too. So if you ever want to expand to making native applications, you can focus on just using that API that one way. And with that, you're able to create web applications and your front-end developers, that's us. And that you would be able to just fetch your data, and you would be able to create applications that work on any device. And so, yeah, that's basically it. And that's something that I'm definitely hoping that you guys get to take away. The idea that having something on the server and having something on the client, that's something that gives you the best things for both your users and for your development team as well. So thank you.
Thanks, Clarence. We do have time for questions. If anyone has any, we can take a few. Oh, is that me? Back there, okay.
Hi, nice presentation, congrats. One thing that I think that probably I miss out was that why I need to send the templates, for example, in your handlebars example, why I need to send the templates to the client, because I read the same exact post, and what I understood was you are rendering everything on the server, send to the client, and using CSS and do manipulation to express your behavior, right? Like, and when you need something, like when you prepare to refresh very big elements, you fetch again the HTML, and you don't have anything be moving inside the client anymore to do the handling part.
So yeah, the idea that you're suggesting is that you do all of your HTML rendering on the server. So the idea is that you would render partials on the server, if I'm understanding you correctly? Yeah, so that's something that you can do as well, and that's something that you can do with the existing tools like grunts and all of that. And we decided to move the templates over to the client because we thought that it might be easier for people to just fetch data directly. It's easier for you to debug as a developer to just see the actual JSON that's being sent. And then that's something that you can also like expose more easily when you use express state. So by doing that, then it's easier for you to inspect the individual HTTP requests. You actually see JSON data.
Yeah, but the point is not have data anymore in the client, right? Like that's not the point to have abstraction to data acquisition on the server, and you have only events and manipulation of events and doing CSS inside the client. That is not the point, I think. What do you think?
So we want to keep the way that people are building existing single-page apps using like the YUI app framework the same way. And how people are used to doing that is by having client-side templates. So we want to keep that, and that's something that people are already doing today. So we want to make it as easy for them as possible to switch to this new system.
Just a comment on that, the last question. One of the things that we do is instead of sending HTML every time the user needs new data or fresh data from the server, we only send the data. That's a lot less data moving on the wire than sending the whole HTML. That's a good reason for having the templates on the client. But now I have a question for you. Mm-hmm. And it's all about security and exposing the URLs in a very known API. What are the thoughts around that? I mean, we're in an institution that security is really, really important, so that's why.
So yeah, so we've worked on that problem for quite some time. We also want to be sure that like people that are doing like bucket testing, for instance, they're able to securely send those out, and without people like being able to inspect those URLs and finding out information about like a new feature that they don't want everyone to know about just yet. So that's something that we're still working on. We're working on a way that people can better expose just certain routes right now. So that that's something that will definitely come up in the future.